Okay, let's continue talking about the way the muscles work. Now in this case we're going to talk about how muscles work together. Most of our body movements have a pair of muscles associated with them. So for the most part muscles work in pairs. And they can often work in opposite directions, so they're antagonistic muscles. So if we think about this, we've got muscles in pairs. We have one muscle that's responsible for making the major movement, and we call that the prime mover. And then we have the opposite muscle, does the opposite movement, and we call that the antagonist. So a really good example is if we think of our upper arm. The prime mover is going to be our bicep muscle, which is on the anterior or superior part of the arm. And then we have the triceps muscle, which is on the back of the arm, or the posterior part of the arm. When the biceps flexes, it moves the lower arm up. When the biceps relax and the tricep flexes, then the arm will be extended. So as one muscle contracts, the other one relaxes. So they work in pairs, and they often work opposite of each other. Now we'll also have some muscles that are about our body that help us steady our body. They help aid in posture. So these can be activated most of the time, and we'll call those muscles the synergists. So a lot of the muscles that occur in our trunk, for example, are going to be synergistic muscles. Now, in order for us to understand movements and body mechanics, we do have to have an understanding of very, very basic physics. So if you're taking a physics course, this will probably be pretty easy for you guys. Now, the musculoskeletal system in itself acts as a lever system. Okay, the lever, of course, is going to be the bone. The fulcrum will be the joint, and the force is going to be applied by the muscle in response to a stressor or gravity. Now, we've got three different classes of levers: first, second, and third class. The first and second classes rarely happen in body systems, but the third class is the most important type of lever. I don't want you guys to get too hung up on this. I'm going to go through it really quickly on the next slide, but you don't need to worry too much about this particular topic. So here's a look at three different types of lever systems. We've got the first class lever here, which is an A, and this rarely happens in our body. In fact, this is probably one of the only instances where we see a first class lever. Now, we classify these levers based on where the force and the resistance is in relative to the fulcrum. Now remember, the fulcrum is going to be our joint. The resistance is going to be generally gravity for a lot of times, but it could also be a weight that we're picking up, and the effort is going to be the force exerted by our muscles. Okay, so in the first class lever, you can see that the fulcrum falls in between our effort and our resistance. So if we were to take the biological example, the fulcrum is going to be at the joint between our skull and the atlas, the first vertebrae. The effort is going to be put in by the muscles in the neck, and the resistance is going to be the weight of the head going forward. Okay, it's a first class lever. We don't find them very often. It's the way that the body is loaded. A second class lever, we can find an example if we go up on our tippy toes. If you look at the placement of the fulcrum, our joint is going to be way towards the one side, so our fulcrum is on one side, and the resistance and the effort is effort's on the opposite. The resistance is in the middle. So the good example, this is a wheelbarrow. The fulcrum will be the wheel at the front, and that's the equivalent to our joint. The weight, the resistance, is going to be between the joint and where the effort is, where the muscle is going to be. So this is a second class lever. Again, not found in many body parts, so nothing that we need to terribly worry about. It's the third class lever down here that's going to be most commonly found in body systems. Okay, in this case, we'll have the fulcrum will be on one end. That's going to be our joint. The resistance will be at the other end. So that's the force of say we're going to carry a weight, and the effort will be somewhere in between. So this is a really great example would be our biceps and our lower arm. So our fulcrum is going to be the elbow joint down here. The weight will be at the hand where we're holding, so it could be a shopping bag or something like that we're holding. and the effort is going to be between those two. So the muscle attachment at the radius is going to be down here, and that's going to be our third class lever, and that's going to be the most common type of lever system we'll find in our bodies. Now guys, I have changed the order of the slides for this particular video, so it's going to come a little bit out of order from your notes, but all the slides are still there. I've just changed the order that they're in. Okay, so we're going to talk about two more topics before the end of this unit, and this is the second last one when we talk about some disorders of the muscles. Okay, now common terms that we use when we're talking about muscle disease or muscle pain, we talk about spasms, strain, spain, or atrophy. Okay, a muscle spasm is when the muscle contraction doesn't relax. And this can be quite painful if it happens for a long time. A lot of times you'll hear a muscle spasm called a cramp. If you've ever had a cramp in your lower leg, in your calf muscle, these can be really, really quite painful, not comfortable at all. That's a spasm. Strain is caused by basically overuse of muscles. You strain your muscles, it puts tension on them, it causes an overuse injury where a muscle is fatigued or slightly damaged, and that's called a strain. Now, a sprain is a more severe form of a strain, and that could involve the tearing of ligaments around a joint. So a sprain is a much more serious injury than a spasm or a strain, because it usually involves some type of damage caused to the muscles. And then atrophy. Atrophy is generally a negative word when we're talking about anatomy and physiology. Atrophy means a wasting or a decrease in the size of muscle caused by a lack of use. So if you've ever broken a bone and you've had your bone in cast for a long period of time, when you take the cast off, the muscles around that joint or around that bone will have atrophied. You would have lost muscle because you haven't used them in a long time. Now, there are some other muscle disorders we can talk about. Muscular dystrophy, for example. Now, this is a category disorder, so there's several category disorders that fall under this title. And this is where we see a deterioration of the muscles. So the muscles start to atrophy, start to become less efficient, less functional, but the nervous system is still intact. So the brain is still sending signals, but unfortunately the effector, the muscle, isn't capable of carrying out those signals. There's another form of disease called myasthenia gravis. Now this is caused by really bad fatigue, so muscles really, really tired following the slightest bit of exertion or action. And this is caused by some type of defect in the transmission at the neuromuscular junction. So when we talked about the synapse and where the neuron meets the motor end plate, there's a problem somewhere in that junction, and as a result of that, the muscles aren't working efficiently and not receiving the signals from the central nervous system as they should. A condition called myalgia is when we have inflammation of the muscle tissue. Okay, inflammation is something we'll talk about later on in the unit, but for now you can think of inflammation as a condition where the tissue is affected negatively. It's caused by either the immune system or it's triggered by some type of pathogen. And then we can have fibromyalgia syndrome. Now this is a disease where you have widespread muscle aches, tenderness, fatigue. It's a relatively common disease in the population, but it can be terribly difficult to diagnose and pinpoint. Some other common disorders we can see with muscles include tendinitis, which is an irritation or inflammation of the tendons that connect the muscles to the bones, and this can be quite painful. It generally goes away after a short period of time, and it's generally caused by overuse. So if you're using a muscle over and over again, playing a sport for the first time, or practicing too hard, you can end up with tendinitis. Another one there is shin splints, and this is commonly found in runners who've changed their routine, or they've changed the way they train, and this causes, again, repetitive stress injury. around the tibia and the connective tissue holding the muscles to the tibia in the leg, the shin bone, and it can be quite painful. Generally, it can be treated with rest and ice, but in some cases it can be pretty severe. Another thing we should note is that as we get older, there's a general decrease in the number of muscle cells we have. So if you're a bodybuilder, for example, and you're quite young in your 20s, even if you keep doing the same type of routine you did in your 20s, once you get past 40, where this decrease starts to begin, you'll see a decrease in your body size because of this loss of muscle tissue. So it starts at around age 40, and it becomes noticeable as we increase in age. Okay, so the last topic we're going to talk about in this unit are the muscles themselves. Okay, now there's a lot of muscles that move around our body, and I don't expect you guys to be responsible for all of them, but we'll go through a few just in case. One thing that you should keep in mind when you're talking about muscles is the naming. It's easy to figure out where a muscle is located, what it does, just based on the name. So you can see here there's a bunch of factors that go into naming a muscle. The location, the size, the shape, the direction of the fibers, the number of attachments, the action. All of these things can give you a hint about why the muscle is named, or from its name, what the muscle actually does. So a lot of times you can have it named by location because it's named by a bone. So, words like lateral, dorsal, internal, or medial, they'll all give you an example of a bone, a placement next to a bone. The size of the muscle makes a difference, so maximus, major, minor. This will help you orient yourself when you're talking about different muscle groups. The shape of the muscle, so some muscles are triangular, for example the shoulder muscles, so they're called deltoids, or the trapezius muscles, which are a trapezoid shape. The direction of the muscle fibers, so if a muscle is called rectus, for example, it has straight up and down muscle fibers. If it's called an oblique, then it has angled muscle fibers. We can also base this on the number of attachment points to the origin. So a quadricep would have 4 attachment points. A bicep has 2. And then we can also classify it based on the action. So a flexor or extensor or adductor, that all describes the range of motion that muscle carries out. Now here's a look at the body with the major muscles labeled. I don't expect you guys to know all of these muscles. What I would expect you to do though is to follow along with the slides for the rest of this unit. We've broken this up into 4 different groups: the muscles of the head and neck, the upper extremity, the trunk, and the lower extremity. Now what I would expect you guys to know is two or 3 muscles from each one of these groups. Okay, I'm not going to tell you which ones you need to know, but you should know 2 or 3 muscles from each one of these categories. And now the easiest thing for you guys to do is to go through the next few slides and have a look at the pictures. So for example, if we have a look at the head, you can see all of these muscles here that are labeled for different functions in the head. If you go down to the next page, you'll see these muscles are named, the location is given, and then you get what the function of it is. So for you guys, what you should do, pick 2 or 3 of these muscles, understand what the location is, and understand their function. Okay, so that's one of 4 different categories. The next one you go to will be the muscles of the upper extremities. Now there's lots of muscles in the upper extremities. Okay, so there's a big list here. Again, location and what they do, what their function is. So that's one table. These are also of the upper extremity. So you can pick through these as well. And then this table here is also from the upper extremities. So like I said, you guys should be able to understand 2 to 3 muscles per major category. So we had the head and neck, the upper extremity, the trunk, and the lower extremity. So in total, you should probably know about